Good evening. It's really good to see so many people here today. And by really good, I mean absolutely terrifying. My name is Ian Donaldson. I am a consultant at DS. What's a consultant? Well, at the moment I spend a lot of my time doing CI. And hence the title of my talk, CI from Docker Guy, which is a lie. This talk is not about CI from Docker Guy. This talk is about Docker for the CI guy. But I couldn't resist the urge to make a pop culture reference, even if it's a little bit dated. So who in this room is a developer? Who develops software for a living or in their own time? A lot of you. Who's used CI? Who actually uses CI? Wow, a lot of you. Did anyone actually not know what CI is or has never used it? One guy over there. There you go. CI, continuous integration. So the basic idea is you have a team of developers, they're all coding away merrily, and when they commit their changes, you would like something to happen. Hopefully you'd like your software to compile or test or deploy, or something should happen other than just sort of sitting there and looking pretty. So the CI server sits there and it looks for code changes, and when those changes are committed, it runs something. That's CI in a nutshell. So I spend a lot of my time working with CI. I do a lot of developer support. So I'm probably a little bit too excited about CI, so I apologize for that. And for the next slide. If it will come up. Let's try that. There we go. All right. History lesson. So CI has been around for a long time. 2001 is the oldest CI system that I can come across. It was called Cruise Control. But I'm willing to bet that if you're working with CI in an organization, you're probably using one of these three: TeamCity, Bamboo, and Jenkins. These guys are kind of the...
Can you even more closer to the microphone?
Oh, hello. It's not switched on. You can't hear me? How about this? I'll try and speak louder. How's that? Can you hear me? Alright, cool. You're probably using one of those three, okay? They have been around for more than a decade now. They're probably the most common CI tooling that I come across in my day-to-day jobs. I put a little code down the bottom. Running CI, what we've seen recently is kind of the rise of hosted CI, or CI as a service, if you like. These guys in blue, Travis, Circle, Bitbucket Pipelines, and AWS Code Build, they're all pretty recent. And they're hosted CI, so you don't have to run that thing yourself. Okay? It's CI as a service. Keep talking. Keep talking? All right, cool. And then we have my favorite here, BuildKite, which is a really interesting hybrid model where they run the master, but you get to run the agents. And I'll talk about that a little bit later. So, anyone here actually have to maintain CI systems day to day? Is anyone's job to do that? It's quite a few people. So I've spent plenty of time maintaining CI, and it kind of looks like this. Yeah, everyone comes at you with everything. My build's failing, can you fix it? It's not going fast enough. This team over there has just switched to Node 357, and I need that on the agent yesterday, which is about to deploy. Or the opposite, which is just as bad, like someone comes along and says, we have to use this library that depends on Java 1.5 or something like that. That is a huge pain in the neck. And infrastructure in the builds. So we're seeing increasingly people want to do more and more realistic testing of their stuff before it goes out, and that means they want something that looks exactly like production or very close to production, but they want it running in the context of the CI server. So your CI server becomes a microcosm of your prod environment, which means a lot of work for this poor guy here. So how can we actually use Docker to make that a little bit easier? So I'm going to walk through an example project. I have a project called Pet Shop, which is a Spring demo project. And I chose Java not because I like it, but because I hate it. Because we do these things because they're hard, not because they're easy. So, let me see if I can get this up. So we have, there we go. I'm going to go make this bigger.
Hey, Can you hear me?
I can't type it.
Oh, maybe I can hold it for you. That's a bit tinted.
That doesn't sound awesome.
I can hold it if you want. Do you want to project?
How well can you hear me at the back? Not at all. Not to worry. Alright. Is the number one?
Oh, hold on.
Yeah, what? Yeah, what?
Hello.
Alright, how about now? Can you hear me? Kevin?
You've got to stay that far from the mic.
Right, so like fade out, fade out, fade out, fade in, fade in, fade in, fade in. Yeah.
Like this.
You gotta be on. I'll see what I can do. Where was I? Alright, so I've got my project here. This is a standard Maven Spring project. Let me see if I can. I won't try running it. So this thing obviously depends on Java. So I need my mouse pointer. Here it is. Alright. Here we have a project, so I'm not going to dive into this. What is that doing? I have no idea. Alright, so we've got our Spring project here, and we want to make this thing easier to run in our CI, and I'll show you. I'll step through that now. So, what's the simplest possible thing we can do to Dockerize this particular build? I'm sorry, I'm struggling a bit to find my mouse pointer. There it is. So, hopefully I've got, there we go, simple build script. So, the simplest thing I can do is just wrap this in a little build script. Here we go. What's that? 4 lines? 5 lines? Really simple. I have my build container, so I'm going to use OpenJDK from the OpenJDK project, and I'm going to call Maven package on that particular thing. So if I just do a meaningless change and commit that out, meaningless change. There we go. Sorry, I'm struggling here. There we go, and sync that up, and let's find our CI so we can see what that looks like. Alright, here we go. Cool. Let me make that bigger. Alright, so simple build right up the top there. So, I think this is kind of lost sync. Let me reload that. There we go, meaningless charge. So you can see that my CI server has picked up that push, and it's now running my build script. We can see that here. Go away. So there's my stage. I read my part, and now I'm going to compile it. And this thing is going to spit out downloading jars for about 6 minutes. We're going to sit here and watch that happen. I'm not that cruel. So I'll just wait for it to start. You can see here, it's running my build script, and you can see it's invoked Maven, and so we actually are running our build script in the context of the Docker container. You can't really tell from this context, but it is actually running inside that Docker container. And if we look at the demo, at the build I prepared earlier, we should see that that will take about 6 minutes to run. So that's all cool, but I can see a problem already, which is I'm running this thing in the context of the build container, so all this work that Maven's doing to download stuff and cache it is going to be repeated every single time that I run this build, which is obviously amazingly inefficient, and developers are really impatient people, and they always want their builds to go faster, and they're going to come and complain about that. So how can we make that faster? So the basic problem we have, I can go back to my slide. Is state. So the power of Docker is that it presents you with this stateless environment that is fresh and new every time. But sometimes we want that state, particularly with build systems that download the world, like Maven, like Gradle, and like NPM. We'd actually like to keep these things between runs. And luckily with Docker we can do that. So we can use volume mounts. So we can persist that data outside of our container and then mount it back in to our build every time we run it. So let's have a look at what a really simple example of that would look like. So my build agents are running inside AWS. So I have access to the AWS SDK and AWS resources to help me with this. Nice pointer, where are you? Thank you. Okay, so a really simple approach to this is to just, what I've done is, let me show you the, so inside my build script, I know that my build dependencies are cached in that .m2 directory. I don't know why it's called M2, maybe version 2 maybe. So I'm actually mounting that under my project as /cache. So you can see that there, I've actually mounted that. And then before I actually do my run, that's not distracting at all. Before I commence my run, I actually just sync my build dependencies off of an S3 bucket. Super simple, super easy, and super cheap. Because S3 is very economical pricing. When I finish my run, I just sync them back again. That's all there is to it. The nice thing about this approach is that if I have multiple build agents, it still works. If the build dependencies change, like somebody commits a new version, bumps a version or something, it still works. So I like it because it's kind of crude but effective. How's that? Yay. I'm so sorry. From up here I sound really loud. Alright, so we start the build and it goes for 6 minutes. Alright, so here's my caching strategy. It's simply caching to S3. So I could show you the bucket that the objects are in, but it's not very interesting. So the point that I was making was I might have multiple build agents. So some organizations run with one build agent because they're very small. Some organizations need literally hundreds of things because... Hello?
Yeah, what exactly you are caching? Like, is it the...
Sorry, I was having to explain this very well. So when the Maven task runs, the first thing it will do is download all the dependencies for the project. And you can actually see there are so many dependencies that my build log has actually become truncated. So it's just downloading all the libraries this project depends upon. That takes a good 4 minutes to do every time. Now, when the Docker container terminates, those dependencies are lost. I want to keep those between runs so that I don't have to re-download the internet every time I run this job. Yeah?
So we had a similar situation earlier. So I think what we did was we had a customized Docker image.
Yeah.
We were doing like Elasticsearch and Kibana.
Yeah.
So instead of downloading a CentOS OS, we were downloading that particular specific image.
Yeah.
And when you pull that image once, you don't have to pull it again because it's already there in your local repository.
Yeah, so there's multiple ways to get around this. This is just one approach. As I said, one of the things I like about this approach is it's simple. And also, it automatically, because we sync the cache back when we're finished, if those dependencies change from run to run because software evolves, you will get that updated automatically. Another approach will be to build the dependencies into the container and build the whole container. But now I have a container that's specific only to this project, or I have a container that might be building 14 or 15 different projects, and now the container is like 5 gigabytes. Now, another approach we could use is we could use something like a network file system like NFS or Amazon's EFS product, and mount that onto the agents, mount that into containers. Okay, that's maybe a little bit more sophisticated. I won't show you that tonight. So, how much time does that save us? I'm not going to do the run if I can find my project. Okay, so we called that simple build script plus cache. There we go. So our previous build was about 6 minutes. By doing a little bit of simple caching, we've got that down to 2 minutes and 40 seconds, 2 minutes and 30 seconds. So multiply that by however many builds a day you want to do, and that's your kind of total time saving. So, what are we going to do next? So I've shown you how you can do this manually just by hacking your build scripts. And the advantage of this is it kind of works with any CI. You don't have to have any particular support. You can run this on Jenkins or you can run it on whatever. As long as your build agent has Docker installed, this approach will work. And it'll actually work from the command line as well, so I can just run this on my laptop and it will work the same as it does the CI. So it has the advantage of simplicity. However, what we're seeing is that CI systems are becoming more and more integrated with Docker, and some CI systems like Circle CI, like Bitbucket pipelines, like BuildKite will actually give you first-class Docker support. So rather than having to write all these little fiddly build scripts for myself, I can actually leverage the CI to do some of the work for me. So what does that look like? There we go. So I'm going to use Docker's BuildKite's Docker Compose support now. So what that means is we drop a Docker Compose file into our project, and actually you can see that this is doing the same thing as what my build script does. It's just saying I'm going to have a build container, and it's going to mount the project as /work, so I can actually access my source. And then in my pipeline definition, my pipeline definition, which I haven't gone into before, and I apologise. What we say is we're going to use the app container to build our project. And what we do is we actually run the command, and that command will be executed in the context of that Docker Compose. So where you see Maven package, what it actually will do something is like Docker Compose -f, Docker Compose.yml, run, app, and then this thing. So it kind of simplifies things a little bit. I actually didn't show you the Docker file for that, but it just says OpenJDK8. So we'll run that, we'll put it into our compose like this, and we'll use it to run this command. Okay? Straightforward, simple. So what does that look like? Very similar. It's not that exciting, I'm afraid. What it does mean, though, rather than seeing something like kind of anonymous in my build step, like build.sh, I should actually be able to see the actual command that I ran in here somewhere. Yeah. Sorry, the logs get so long you kind of lose context of the code, which is sort of painful. But yeah, you can see that the app has built. It's built with my Docker Compose. That's now there in the project for anyone to inspect. If they need to change that, it's pretty straightforward how that works. So the observant above among you might notice that we have lost our caching as a result of doing that. And now our builds are back up to 6 minutes and 43 seconds. So here's the limitation. I've told BuildKite from now on, run everything inside the context of this Docker container. So I've lost the ability to act upon that build from outside, if you know what I mean. So I need to use a different strategy to actually achieve caching. I could install the AWS tools into the container and do my old S3 sync. I could do something using a network file system. There's a couple of other approaches I could use. But yeah, there is that limitation. You tell your CI to work within this Docker container, your context is bounded by that Docker container. You can't so easily break out of it and do other things to it. So the final thing that I wanted to show you was that quite often we get asked to provide infrastructure in the context of our build, and of course this is bread and butter for Docker. We can do that very easily just by adding to our Docker Compose file. There we go. So all I've done here is just added in a MySQL container. I have linked it in. My build script doesn't change. This is for the purpose of running tests. So this is a build and test stage. So I'm going to run up my Docker container, run up MySQL, run my tests against that, and then shut it down. I'm not going to deploy this out. This is just for running my build. I don't think I need to show you that in BuildKite, right? Pretty straightforward. So where does it get us? Okay, so I talked a little bit about this. Should you use the pipeline support, or should you do things with scripts? It probably depends how hands-on you like to be. I'm comfortable doing things with scripts. I like to have full control. and it's independent. If you wanted to change from Jenkins to, I don't know, whatever, Bamboo, God help you, you can keep all your scripts the same, they don't change. Once you start doing things inside Circle CI or Bitbucket pipelines, you're kind of a little bit tied to that system without a little bit of extra work to get off it. But it is easy to engage with. So if you're looking after a development team, they're not necessarily very Docker aware, they can kind of pretend that Docker doesn't exist. They're just writing their build steps as if they were running them on a local machine. They don't need to know that Docker's there. So that might be a real positive if you're kind of supporting a team of developers who don't really want to engage that strongly with Docker. So, I don't know, pick your poison. So, where do we get here? Good practices. Keeping your agents clean. So, kind of the key to making this all work is pushing people, guiding people down a path where they take ownership of their own build scripts. Okay, so if you want to start up a Haskell project, that's fine. You define your build container and you go for your life. You want to do unit tests against Redis, I'll help you add that to Docker Compose, but then you own that and then you run with it. If you start customizing your build agents for every little project, you're kind of back in that bad place where you're just really dealing with competing priorities. So very much you need to push back on requests to customize your agents as much as you can. Keep them clean, guide people down that Docker path where they're managing their own build dependencies. And I might just give a bit of a call out to build kite Elasticstack, which I'm a huge fan of. So if you use BuildKite, you don't have to use their stack, but if you do, there's this lovely auto-scaling AWS BuildKite stack available here on their GitHub. You can download that and you can be up and running in about 10 minutes flat. It's awesome. It scales according to the number of jobs in your queue, shuts everything down when there's no jobs to be run, so you save a lot of money. Supports Docker and Docker Compose. It's got a lot of niceness around working with AWS. So if you're deploying into AWS, I recommend this. In terms of what's on each machine, there you go. The BuildKite agent, Docker, AWS, and JQ. And that's it. Nothing else. No compilers, no runtimes, no environments. Definitely no jQuery. Just that stuff. So that's a good example of the kind of philosophy that we're aiming for. What else? Lost my last one. There we go. Separating your build from deploy. So your build is your build, and your deploy is your deploy, and they have separate concerns. So my build environment might be a very fat environment. It might be running lots of libraries and containers and development environments. But my deploy environment, I want to keep that as skinny as possible. So I like to separate the build from the deploy by making sure that all my builds end up with some kind of artifact. So that might be a jar file if it's a Java project, or a gem if it's a Ruby project, or a zip file if it's a Node project, or possibly even you're not going to deploy into Docker. Well, you might be producing Android packages. You can build Android using Docker, it's fine. And your output's an APK, which then goes on to the device. So once you've generated that, you kind of want to put it somewhere. You've got a record of it, and you can kind of get back to it if you want it. So that could just be an S3 bucket, or you could be using a commercial tool like Artifactory or Nexus, Sonar Nexus. This multi-stage build thing that's in Docker, it's kind of the opposite of this, where you kind of move your artifacts between stages without actually breaking out of your Docker file. The reason I really like that is if my build failed, I'd like to know about it here. Like in terms of my CI, I'd like to see that build step, that test step, that package, that deploy step. I'd like to see them separated, so when there's a failure, I know where it happened. If you wrap everything up in one kind of giant multi-stage build, some feedback is going to be lost, and I think you're going to find people get confused. So it's a really cool technology, but I don't really want to use it. At least not for builds anyway. And the third thing I want to talk about is using good build containers. So We're reasonably trusting these days. I remember back in the old days before Docker, and people would try and sneak exploits into GCC. So, come across GCC, it's kind of like a fundamental compiler that underpins most of our ecosystem. So people would try and put exploits in there. And people would get quite nervous and paranoid about making sure that their GCC or their compiler toolchain was from like a known good source. They would check MD5s or PGP signatures or ring up Richard Stallman and ask him if it was okay. These days, we like find a Docker file on Docker Hub, and like, that looks good, I'll just pull that down, it's all good. And my entire enterprise is now dependent on some random dude's Docker Hub password for its security. So I'm just waiting for the day when some organization gets completely and utterly owned through that vector. I'm sure it will happen one day. Someone will sneak something into a commonly used build container, it will just push out malware all through the organization, and I'll just come back and say, I told you so. So, no good build containers. There's lots of official ones you can use. These are great. These guys do all the work for you. You should use them. They are mostly not based on Alpine, because Alpine is not... Alpine can bring its own little set of problems when you're trying to do compilations. Sometimes you get weaknesses around libc and so forth. Because that build container is going to be used like 100 times a day, it doesn't need to be really, really tiny. It needs to be really, really stable and reliable. So here's some official build containers you can use for your projects. For Android, OpenJDK, and then Android SDKs. You probably need to build that yourself and put it somewhere that you control if you're building Android. You might want to use tools like TwistLock if you are building build containers. You might want to use security tools like TwistLock to validate you are actually using the container. You could definitely talk to them about that. And as I said, it's not really that important for your build containers to be tiny. Don't micro-optimize on these things. It's going to get downloaded on your page. It's not a big deal. Finally, developers are my customers. I'm trying to improve their UX, and Docker is a key part of that. So if you're maintaining a CI system, empower them. Empower them to control their own destinies by controlling their build environments. And let them actually run without your intervention. And that's it. Thank you. Any questions? Hello.
Hello. Thank you for answering my questions, Sandy. I didn't know that there's a separate slide for questions. Second thing is that you mentioned that somebody could sneak a malware inside a container.
Yeah.
But when we run a container, we make sure we can suppress the ports. So we can suppress that it will only expose a port 9200 or say. So whatever it's doing this inside that container. It will be like, it won't spread to enterprise. That's what my thoughts are.
So if I can inject some malware into your container, I can use that to change the behavior of your application, which is listed on the port and exposed.
Oh, excellent. Point taken.
Yeah. Yeah.
Ian, something. Just a question about the build kite stack. Do they support Spot instances yet, or are they still?
Absolutely, yes, it's built in. So you can use Spot instances or regular instances or a mix of both. And that's actually a really good point. I had in my speaker notes. But yeah, Docker for generic build agents means using Spot instances is very easy. It's a nice little statement.
Multi-stage build will help us to reduce the size, Docker file size.
I'm sorry, I didn't catch that.
Whatever the multi-stage build you have suggested, right? Will it help us to reduce the Docker size, Docker file size?
So I actually suggested not using multi-stage builds because I want that feedback. So if I did this in multi-stage build in my CI, that would be one build step. Okay, and if it went red, I would then have to dig into my logs to work out what went wrong. If I do these things in separate stages, I get better feedback in my CI tool about what went wrong. So not to use them, to actually kind of do things a bit old school, and always capture your artifact before you move on to deploy. Yeah? Yes?
Have you used or looked at using Docker's new relatively new content trust stuff for signing the resultant Docker file, the Docker image that your Docker file generates?
I haven't, but it sounds really awesome, and I'd love to talk to you about it.
Okay, cool. I'll talk to you after.
So that's using Notary
Yeah.
put things up.
I'm currently grappling with some problems around using Docker in a PCI compliant environment. And the QSA is talking about things like file integrity monitoring. I'm saying it doesn't make a lot of sense in a Docker world because it's a read-only container. So I'm interested in other approaches to that might be more sensible.
Just like, so.
And twistlock might be the answer. Anything else?
Awesome.
Thank you very much.